We have successfully created a web server that uses promises and serves a static HTML website. At the moment, we are using the fs.readFile method to read files in, and herein lies a problem. The fs.readFile reads and buffers up each and every file into memory before flushing it out to the response. For simple usage, this is quite okay and you won't run into a problem. But imagine if multiple users request heavy files, such as let's say a 500 MB file. In such a case, fs.readFile would choke your server's memory in order to first buffer up the entire file before it can send it through. That doesn't sound good now, does it? Additionally, memory usage and performance takes a hit because there is nothing that governs the speed at which data is being read in from disk versus the speed at which the data is flowing out through the response. If the outflow slows down due to some reason, there is no way to tell fs.readFile to stop reading the file till the buffer is able to take in more data. So, reading and serving files to a large number of concurrent users is not something that we should be doing using the fs.readFile method. Fortunately, Node.js gives us streams. Imagine streams to be like pipelines that carry data and can also control the flow of data so that if the outflow slows down, the inflow can be regulated. Additionally, and the biggest feature of streams is that data is not read in all at once, but instead it is read in as small chunks traveling continuously. So, as a file is being read in chunk by chunk, it doesn't need to sit and collect in memory because it can be piped out at the same time. So a 500 MB file will be read in small chunks and piped out chunk by chunk in real time to the user through the response. And if the outflow slows down, streams will slow down the read stream to manage the flow. This is incredibly smart and one of the reasons why Node is so amazing. And this is not the only place where you can use streams. Your HTTP server instance as an event emitter already uses streams. That is why it is so efficient in the first place. And you can of course read and write files using streams and also compress and decompress files on disk. Getting back to our web server, let's get rid of fs.readFile and bring in the goodness of streams. So first, let me resave this file as webserverprostream.js. Now let's get rid of the file reader function and let me just rewrite this as stream file. Once again, we'll accept the file path as an input to the function. And once again, we'll return a new promise with two possible states, resolve or reject. Now inside this function, we'll first create a variable called filestream and we'll set this to invoke the fs.createReadStream method. We'll pass in the file path here and this is what gets our read stream up and going. Now, unlike the read file method, which just buffers up and provides us with the entire content in one go, the create read stream is actually an event emitter. In fact, streams for that matter are all event emitters. So as the create read stream starts to read in the file, it throws an event called open. So by accessing the file stream variable and using the on method to listen into events, we listen for the open event like so. And once that is intercepted, we'll simply invoke our resolve state by passing in a reference to the file stream variable itself. It's like handing over access to a pipeline that has started reading and providing us with data. If there is some error reading the file, then an error event is thrown, which we are going to intercept using another event listener like so. And by now you should have a fairly good idea what to do with this error. Yes, we'll reject the promise passing in the error status like so. Down in the web server method, we'll replace the reference to the file reader method with stream file, and so far everything seems fine. But now we'll have to make an important change in our function that writes out the content to the response. First and somewhat obvious is bringing the file stream in, since this is what was resolved out of the stream file method. But the important bit here is that we do not need the response.end method here. This is because a stream is a continuous flow of data, unlike before where for every requested file we were just dumping the entire contents of the file as read by the read file from the memory to the response. Therefore, now we'll first access the file stream and we'll use a method called pipe to literally pipe out the data to the response like so. And that's all there is to it. Data flows in from the file, gets piped out to the response. Not only is this quite simple to understand, but it's also quite simple to implement. So one last time, let's fire up our server. And it works as expected. So this is how you can write a web server that stream reads every requested file and streams out directly into the response without killing your server's memory. Once again, all these files are available in the download section.